Hello, so this is the Unit 7 Lesson 2 on graphing logarithmic functions. So our learning objectives today are to graph logarithmic functions, right, when we're given an equation. We're also going to kind of look at the properties when we're given an equation, so not necessarily looking at the graph, but just being able to look at the equation and tell me information about the function. And also being able to look at a graph and then tell me some properties about the log. All right. So one essential thing here about a log function is that a logarithmic function are inverses of exponential. They are inverses of an exponential function, right? So remember what an inverse is. An inverse switches the x and the y value, all right? And that's going to be a little bit tricky when you're given a log function, but we'll try to make it as easy as possible. So, like an exponential function that has a base, a log function has a base as well. That 2 is called the base, right? So we would read this, y equals log base 2 of x, right? You would read it, y equals log base 2 of x. So again, the 2 is the base, and that's going to be important when we switch it into exponential form. All right? So an exponential graph has a horizontal asymptote of y equals 0. So all log functions will have an asymptote of x equals. Now, the parent functions of these will be 0, but of course it can shift left or right. So it could be a different number, and we'll get into that. You'll be able to tell it from the equation. But remember that a log has an asymptote of x equals, and it's going to be vertical. Okay, so converting to exponential form. Y equals log base 2 of x will be switched to x equals 2 to the y. Log functions, again, the domain and range switch when we're talking about inverses. So the domain will be restricted from 0 to infinity, and the range will be negative infinity to infinity, which again, you should recognize that as an inverse of an exponential function. All right, so we've written out the steps of how to graph a log here, right? These 5 steps. This step here at A, you don't always have to do it. It just depends on what the function has, if A has been stretched or compressed, or if it's been reflected. All right? So sketch an asymptote, x equals 0. We can sketch that in here. Put it right there on the graph. Then we're going to make a table of parent points. So this is delta x, delta y. And again, because the y is my exponent, right, I'm going to pick negative 1, 0, 1, and 2. And then I'm going to plug those points in to this function, right? So 2 to the negative first is 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 squared is 4. So now I have a set of points that I can graph. I have no a value here, so I don't have to do this step for my initial equation. Plot the points from the asymptote. So from here I can move over 1/2, down 1, over 1, stay on the line, over 2, up 1, and then over 4, up 2. And there is a logarithmic function. You want to be careful again. This graph should not cross the asymptote. Vertical asymptotes do not get crossed. So don't make your graph go over it, or we'll take points away, right? You must demonstrate you understand that. So after I plot the points, I would shift up or down. There was no shift up and down going on, so that's my graph, all right? And that's the basic log graph. We can talk about the end behavior. So we can talk about as x approaches. See, x will not approach negative infinity. It will approach the asymptote. So whatever my asymptote is, that's what's happening on the left side. X is approaching 0. What is y doing? It's going down. So I'll say negative infinity. On the right side, x is approaching infinity. So y is approaching positive infinity, because even though it's leveling off, it will still continue to rise forever, and there's no upper limit. Okay? So that's a basic log graph that you're going to need to do. So let's take a look at a few examples. Again, we have transformations as well. So, but here's the basic equation, right? We have a values in the front, which are multipliers. We have shifts left and right inside the parentheses. We have shifts up and down outside the parentheses. So looking at this equation, y equals log base 3 of x plus 4 plus 2. I know that this would be converted into x equals 3 to the y. All right, so when we convert this, we're not going to worry too much about the stretching and compressing, the shifting left or right. Just convert it. You have base 3, so x equals 3 to the y. So I know that my asymptote is going to be shifted to the left 4, so x equals negative 4 is my asymptote. So sketch that in, negative 4, there's my asymptote. And then I'm going to make up parent values, delta x, delta y, negative 1, 0, 1, and 2. Again, those are very basic points. I'm going to raise 3 to the negative first, so that's 1/3. I'm going to get 3 to the 0, which is 1, 3 to the first, which is 3, and 3 squared, which is 9. And then I'm going to plot those points. Again, there's no multiplier. So from the asymptote, I'll move over 1/3, down 1. Over 1 on the line, over 3, up 1, and then over 9, up 2. And again, first, once we do that, once we've plotted those points, we now have to take into account this shift up 2. So from that point, go up 2 from the first point. From the second point, move up 2. The third point, move up 2. The fourth point, move up 2. So we get that little shift up. Okay, that's the graph of the example. We can tell the domain, negative 4 to infinity. The graph never reaches will never reach negative 4. So again, it's a parenthesis. The range is negative infinity to infinity. As x approaches the asymptote, negative 4, the graph is going down, so that's negative infinity. As x goes to the right to infinity, y is increasing, so it would be positive infinity. And that is the graph and the properties of our first example. All right, moving on to the second example. This was a little different. This says y equals ln of x minus 1 minus 3. ln is just a shorthand version of log base e. And we talked about that, right? We talked about base e in exponentials. E is just a number. And you can abbreviate e to 2.7 for our purposes of graphing. E equals 2.7. So if I'm going to rewrite this in inverse form, it would be x equals e to the y. All right, I have an asymptote of x equals 1. If I make my base chart here, I'm still going to pick negative 1, 0, 1, and 2. E to the negative first is about 1 over 2.7. Anything to the 0 power is still 1. Anything to the first power is still itself. And e squared is about 7.2. All right? So that makes it kind of nice to remember 2.7, 7.2, right? You should be able to memorize that, and you will need to memorize that. So convert, sketch in your asymptote, x equals 1. And then I'm going to plot my base points. So go over about a half, down 1, over 1, stay on the line, over 2.7, up 1, over 7.2, up 2, so it's going to be about right there. And then I want to shift them down 3. So each point, starting with the first one, down 3. And then sketch it. Okay. Pretty straightforward. Our domain will be 1 to infinity. Our range will be negative infinity to infinity. As x approaches the asymptote of 1, y is going down. As x approaches infinity, y is increasing. Okay. So this last one here is probably the most difficult and the most complex of the ones we're going to do, because we have a multiplier. But let's not worry about that yet. We have a base 2. So if I rewrite this in exponential form, it's x equals 2 to the y. I have an asymptote of x equals negative 5. So negative 1, 0, 1, 2. So 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. Now, I do have a multiplier, so that is multiplied by your y. All right, so negative 3 times negative 1, that's going to become positive 3. Negative 3 times 0 is 0. Negative 3 times 1 is negative 3, and negative 3 times 2 is negative 6. So again, all I did was multiply my y values by negative 3. Now I can graph my asymptote at negative 5. plot my basic points. So over a half, but I'm going up 3. Over 1, and then I'm going to stay right there at 0. And then move over 2, and down 3. And then over 4, and down 6. Okay, and now that I've done those basic points, I have to remember to shift it up 4. So each of these points will move up 4. And then I can draw in my graph there. Remember to kind of curve it. We want it to curve, we don't want it to cross, and we don't want to see a straight line. So don't extend this graph too far to the right. Just kind of get past that bottom point and then stop, put an arrow on it. All right? So that's the graph that's been reflected, stretched by 3, shifted left 5, and up 4. How does that affect the domain? It doesn't. It's -5 to infinity. How does it affect the range? It doesn't. -infinity to infinity. Your end behavior is going to be a little bit different, because as x approaches -5, your y is actually going up. So this would be positive infinity. And as x approaches infinity to the right, your y is going down this time. So when it's been reflected, your end behavior is going to switch. But other than that, that's about it. Okay? So those are the graphs. And you need to be able to graph these types of equations. All right? So we'll give you plenty of practice in class. This back page is pretty straightforward. You should be able to answer all of these questions without too much trouble. So I'll do one, and then you can pause and do the rest. So your asymptote here is x equals -5. Your domain is -5 to infinity. Your range is -infinity to infinity. As x approaches -5, it's not reflected, so it's going down. And as x goes to infinity, your function is going up. All right? So remember, the only thing that's really going to change here is your end behavior if it's being reflected. So pause the video, try the next 2 problems, and then start it up again. Pause the video. Okay. This should be what you have for number 2, the second 2. The only thing that's a little tricky is you should have recognized that negative affects your end behavior. But notice that the 2 does not affect anything. All right? It doesn't matter if you multiply it, it's not going to affect any of the properties. Okay? So we can do that again. Same kind of thing. Now we're looking at a graph instead of an equation. You should still be able to tell me the asymptote. This one looks like it's crossing here at -2, so x equals -2, which means my domain is -2 to infinity. My range is -infinity to infinity. As x approaches the asymptote, the graph is going down. As x is going to infinity, the graph is going up. All right, so pause the video, try this next one, and then you should have it. All right, pause the video. Okay, and here is the answers to the last question. Again, this stuff should be pretty straightforward, but you have to be able to keep the difference in your mind between exponentials and logarithms, vertical asymptotes and horizontal asymptotes. So if you have any questions, let us know. Otherwise, we'll be practicing graphing logarithms in class. Have a good day.